All right, this is the remaining examples from the 3.2 notes. It says sketch the graph of the equation and label the x-intercepts and y-intercepts. Then use the test for symmetry to determine which graphs in the indicated exercises are symmetric with respect to x-axis, y-axis, or origin. I will show you how to algebraically show the test for symmetry for each one, but you should be able to see symmetry from the picture, and that's all we require that you know how to do for the exam. So for this first one here, even if we didn't know how to do it, but we already do because we've gone over some line graphing now, we would start off by finding the intercepts. To find the intercepts, you plug in 0 for x to find the y-intercept and 0 for y to find the x-intercept. So if I want to find the x-intercept, I plug in 0 for y. And if I want to find the y-intercept, I plug in 0 for x. Usually the y-intercept's easier to find. This is just y equals 2, so that would be 0, 2 is one of my ordered pairs. On this one, I would subtract 2 and then divide by 3. So negative 2/3. So my x-intercept is negative 2/3, 0. My y-intercept is 0, 2. So I could actually graph the line with just that information, but I'm going to get one more point just to have a good check. So if we plug in 1 for x, that would be 3 times 1 plus 2. So that's going to be 5. So if I plot 0, 2 for my y-axis point, negative 2/3 is going to be a little bit less than negative 1, and 1, 5. Notice all of those are in a line together. Now I already know that this doesn't have x-axis symmetry. It doesn't, if I fold it right here on the x-axis, it would make a V shape. It wouldn't match up with itself. If I fold it across the y-axis, I'll just get some kind of horizontal V. And if I do a double fold, it still doesn't match up exactly. So I already know that it doesn't have any of the origin axis or x-axis or y-axis symmetries that I'm looking for. But here's how you do the test for symmetry. To test for x-axis symmetry, you replace negative y for the y's. So you take your equation, you say, okay, wherever I had a y, I'm going to make it a negative y. And then you resolve this for the letter y, so we divide everything by negative 1. If this side does not match the original, then you don't have that symmetry. So no symmetry, so this one's a fail. Let's do the y-axis symmetry. For the y-axis symmetry, we plug in a negative for the x. So negative x for x. So to do this test, we plug in y equals 3 times negative x plus 2. You then work out that sign there. And this is also not the original. So it also fails that test. The final test is the test for origin. For origin, you replace negative x for x and negative y for y. So that would be negative y equals 3 times negative x plus 2. That's negative y equals negative 3x plus 2. We divide everything by negative 1 to make the y go back to being positive like it originally was. And notice this guy right here is still not matching. So that is also a fail. So this is how you prove it algebraically. You plug in those signs changes for the variables, and then you prove that it doesn't match the original equation. So I do want to show you one that has a symmetry. So let's look at this one. I'm going to start off by doing my chart to find my intercepts and maybe another point or two. So 0 for x, 0 for y. If I want to find my x-intercepts, I plug in 0 for y. If I want to find my y-intercept, I plug in 0 for x. This would be 0 squared times negative 1, so that's still 0, so this is 2. This one's a little more complicated. You add the x squared over, and then we're going to take a square root, so it's going to be plus or minus square root of 2. So we actually have two different x-intercepts. And then let's get another point. Let's plug in let's say positive 2 for the x, because that's different than any of those. So y equals negative 2 squared plus 2, so that's negative 4 plus 2, so that's negative 2. Okay, so let's plot what we know. 0, 2. Negative square root of 2 would be about negative 1.4, so that's a little bit almost halfway there. That would be positive 1.4. And then 2, negative 2 would be down here. So this kind of matches with that U shape that we expect. And because this point is exactly halfway between the two intercepts, I know that's my vertex of my parabola. We talked about that a little bit in class. So that's the vertex. Now, this one has y-axis symmetry. It does not have any of the other symmetries. So I already know it has that symmetry, but I'm going to show you the proof of just that part. Because like I said, we're going to be only using our sight on the actual test. You'll just look at it and say, oh, that's the symmetry it has. But I want to show you that I can prove it algebraically. So we change negative x for x. So y equals negative, because that's in front of the x, negative x squared plus 2. If you square a negative, it comes out positive, but you still have that negative that's in front. This is a match for the original. So plugging in that negative x did not change the structure of the equation at all. So that's when it passes the test. All right, let's look at D. This time we have a y squared instead of an x squared. Still going to do my chart for my intercepts. So x-intercept and y-intercept. If I plug in 0 for y, this time that makes this really easy since y is the part that's being squared. That's just going to be negative 4. So I have a single x-intercept. For the y-intercept, though, this time, we're going to get multiple intercepts. We would add 4, divide by 2, and then we'll take a square root. Don't forget to write our plus or minus. So this time we actually have negative square root of 2, and we have another y-intercept, positive square root of 2. I'm going to plug in another value. I think I'm going to plug in a y value this time, because sometimes it helps to plug in a y value if your x is what you've already got solved for. So 2 times negative 2 squared minus 4. That's 4 times 2 is 8 minus 4. That's positive 4. Okay, so let's plot what we know. 0, negative 1.4. So that's about right there. 0, 1.4. Negative 4 is 0. And 4, negative 2. Now, this looks like a parabola on its side, and in fact, because the y is squared, instead of the x being squared, that's exactly what happens. So it still has a vertex, but it's halfway between it happens exactly halfway between the two y-intercepts. So this one has, because it's folded over the x-axis, it has x-axis symmetry. It doesn't have any of the others. It doesn't fold across the y-axis and match, and it doesn't double fold. A quick way to check that you don't have a double fold, notice the point 4, negative 2. If you had a double fold, negative 4, positive 2 would also be a point on the graph, so it's not. So let me show you the test for the x-axis symmetry algebraically, just so you can see that. We would change all of our y's for negative y's. So this would be x equals 2 times negative y squared minus 4. Because it's being squared, that just turns out to be a y squared, and it is a match for the original, which means this is a pass. It would still fail the origin and y-axis symmetry test. And then the last one, because we did the F in class, is the y equals 1/2 x cubed. So we're going to try to find our intercepts first. If I plug in 0 for for y to find the x-intercept, I would multiply both sides by 2, which is still going to be 0, and the cubed root of 0 is 0. So that's just going to be 0, 0, which means I really don't need to solve this other part. I already will, because if the origin is one of your x-intercepts or y-intercepts, it's also the other one. So it's also 0, 0. So that gives me 1 point. So see, that doesn't help me graph this. So I'm going to pick maybe -2 and 2 as 2 other points to try out. I just use them because they're divisible by a half, especially since we have a fraction involved. But we're going to have to cube them first. So that would be 1/2 times -8, so that's -4. And 1/2 times 2 cubed is 1/2 times +8, which is +4. So I get -2, -4, +2, +4. It's not a straight line, and I'm going to prove that to you. I'm going to plug -1 in. So that would be y equals 1/2 -1 cubed, which is just going to be -1/2. Sometimes you do need to do other points as well to prove that it's not a straight line, because this is a cubed function. It should not be a straight line. So if we go -1, -1/2, notice this has a curve to it as it goes down. And that's the best I can draw it. So this is the x cubed shape. Now, this one does not have y-axis symmetry. It does not have x-axis symmetry because that would fold down to this half, but it is a double flip. So this one has origin symmetry. Now, I'll prove that to you algebraically. With origin symmetry, you replace the x and the y both with negatives. This would just be -y. A negative cubed would still be a negative. So this is -y equals -1/2 x cubed. And then you usually divide by the -1 in front of that to turn it back into a regular y. And that is the original. So as long as it works back out to the original, it has that symmetry that we're testing for. And that's the end of the 3.2 notes.